Now we are going to study heat part 2. First, let's look at the definition of heat capacity, 熱容量. Heat capacity of a body is the energy needed to increase the temperature of it by 1 degree Celsius. Let's look at an example of an iron block. If the initial temperature 起初嘅溫度 initial temperature 起初嘅溫度 of the iron block is T1 equal to 20 degrees Celsius. If it absorbs the energy of 400 joules energy, okay, it absorbs 400 joules energy, and its temperature, its final temperature 最後嘅溫度 will become 21 degrees Celsius. That means the temperature increases by 1 degree Celsius. Okay? By definition, heat capacity of an object is the energy needed to increase the temperature by 1 degree Celsius. In this case, since 400 joules of energy is needed to increase this iron block by a temperature of 1 degree Celsius, okay? Therefore, the heat capacity of this iron block would be 400 joules, okay, per 1 degree Celsius, okay? Therefore, the heat capacity of this iron block would be equal to 400. The unit is this one, joule per degree Celsius. Okay? Now, if we let the heat capacity of a body be letter C, and the temperature rise is the final temperature T2 minus the initial temperature T1 equal to delta T. Delta means change in temperature. Okay? And energy need is equal to E. Okay, we use this symbol. From the above example, the heat capacity of the iron block is 400 joules per degree Celsius, with the temperature rise of 1 degree Celsius, and the energy absorbed is 400 joules. For the same iron block, the heat capacity remains the same, 400 joules per degree Celsius. But if we want to increase the temperature by 2 degrees Celsius, okay, this time it's not 1 degree Celsius. If we want to increase its temperature by 2 degrees Celsius, then the energy need would be 400 times 2 joules. What if we want to increase its temperature by 3 degrees Celsius? Very obviously, the energy need would be 400 times 3 joules. If we want to increase its temperature by delta T, where delta T is any temperature rise, then the energy need would be 400 times delta T. Alright? If now we replace the iron block by an object Y, which has heat capacity C, joules per degree Celsius, and we want to increase its temperature by delta T. then what would be the energy needed? Obviously, the energy needed would be C times delta T. Okay? Now, we will have a relation between energy need, heat capacity, and change in temperature. The relation is E equal to E times delta T. That means energy need equal to heat capacity times change in temperature. Okay? This equation is very important. Thus, heat capacity depends on first, mass, second, material. An iron block has a heat capacity of 400 joules per degree Celsius, means that we need 400 joules of energy to increase its temperature by 1 degree Celsius. If now we want to increase the temperature by 1 degree of two identical iron blocks add together, then what is the energy need? Of course, we need 800 joules of energy, okay? Because the mass is double, okay? Therefore, the heat capacity would be 800 joules per degree Celsius now. That means in order to increase the temperature by 1 degree Celsius, we need twice the amount of energy. That means 800 joules. Therefore, the heat capacity of these two blocks add together would be C equal to 800 joules per degree Celsius. From this example, we know that heat capacity depends on mass, okay? A greater mass has greater heat capacity. In fact, heat capacity C is directly proportional to the mass m. Therefore, heat capacity is proportional to mass. Materials can be classified into two types. The first kind is insulator, 絕緣體. Examples of insulators are glass and polyethylene. Polyethylene, this word means 發泡膠. And another type of material is classified into conductor, 導熱體. Examples of good conductor of heat, 好嘅導熱體, are iron and copper, 鐵同銅. We all know that insulators is more difficult to be heated up than good conductor. Since insulator is more difficult to be heated up, therefore more energy is needed to raise the temperature by 1 degree of an insulator than a conductor. Therefore, the heat capacity of an object should also depend on material. That means what kind of substance it is. That is, heat capacity C depends on material. As a conclusion, the heat capacity of the object depends both on mass and material.